So today we're gonna go ahead with the article slash script, more or less about exercising and physical activities in terms of evolution. Because there is, and I've also thought about that, and I've been talking about it in the previous episode as well. But I often thought that, well, we were designed to do something. So it must be healthy and it must be smart to do as well, but not necessarily, not necessarily. And because we evolved and things have changed, we're not living in the same space, in the same time, in the same environment as we have been living back in the days. And back in the days where, our body basically was designed for being in that space and that time, with those predators and those diseases and those other things that could harm us, and so on and so on. So the last time we went through what kinds of physical inactivity are humans adapted for, and today we're going to go ahead with why and to what extent did exercise evolve to be a form of medicine. And I'm going to read. According to my dictionary, a medicine is something used to treat or prevent disease, and exercise is an activity requiring physical effort carried out especially to sustain or improve health and fitness. By any standards, exercise is clearly one of the most potent medicines there is. But why does our history as relatively fat endurance athletes who take it easy whenever possible make exercise medicine? To what extent does this evolutionary history also limit the extent to which exercise functions as a kind of medicine? In addressing these questions, one must keep in mind that since humans until recently never had the chance to avoid being physically active on a regular basis, there was never strong selection to prevent persistent and extreme physical inactivity. By the same logic, there never was selection to prevent obesity. To go a step further, because selection ultimately acts on reproductive success and because energy is a limited resource, one predicts that selection rarely, if ever, acted to cope with the negative effects of physical inactivity. Such a lack of selection should be especially marked for energetically expensive biological systems that require physical activity as a stimulus to adjust capacity to demand. Because costly excess capacity wastes limited energy that could otherwise be spent on reproduction. Natural selection will favor those response curves that adjust capacity to demand economically to reserve as much energy as possible for reproduction. Put differently, since natural selection acts on reproductive success and since organisms must trade off limited energy resources, natural selection will always favor mechanisms that trade off energy in ways that favor reproduction. As a result, the body's physiology and anatomy are adapted to respond to the stresses generated by physical activity to generate enough, but not too much, capacity. A well-studied example of this kind of predicted trade-off between capacity and demand is the dose-response relationship between physical activity and muscle tissue. Since muscle consume about 40% of a body's resting metabolic rate, which is insane if you think about it, individual muscles thus hypertrophy primarily upon demand and degenerate under conditions of disuse. Which means if you don't work out, then of course you're going to use a muscle, because muscle wastes a ton of energy, because as they said, 40% of your body's resting metabolic rate. And the less muscle you have, the less is your metabolic rate, which is good if you think about surviving and if you think about needing as less energy as possible. Well, similar action norms in response to varying levels of physical activity apply to almost every system in the body, including the circulatory system, the skeletal system, and metabolism. And in the circulatory system, for example, vigorous activity stimulates expansion of peripheral circulation, causes ventricular enlargement to increase cardiac output, and increases arterial elasticity. Individuals who avoid moderate physical activity thus develop low cardiovascular capacity, predisposing them to many kinds of disease that used to be rare. See the following section. Walking, running, and other forms of physical activity also generate mechanical stresses in the skeleton that are necessary to stimulate bone deposition and repair mechanisms. As a result, persistent inactivity leads to weak bones that increase the risk of osteoporosis and other previously uncommon diseases. So see the following section as well. Physical activity even acts on the nervous system to increase neural function, helping explain why physical inactivity is correlated with diminished mental health and some forms of dementia. It is worth emphasizing that the many mechanisms by which physical inactivity increases the risk of chronic non-infectious diseases do not occur because physical activity evolved as an adaptation to prevent ill health, but instead they evolved as adaptations to prevent excess capacity in individuals who were already active but energy limited. For example, the protective effects of exercise against osteoporosis are likely a byproduct of selection to prevent costly overbuilding of the skeleton. Seen in this light, the fact that exercise helps prevent osteoporosis is primarily a consequence of the skeletal system, like every other system requiring physical activity to adjust capacity to demand and thus failing to develop normal capacity in the absence of normal demand. Exercise did not evolve as a form of medicine. The argument that exercise did not evolve as medicine because people until recently were rarely, if ever, able to be regularly physically inactive leads to one of the most important concepts in evolutionary medicine: mismatch. Mismatch conditions are defined as diseases that are more prevalent or more severe today than in the past because the body is inadequately or insufficiently adapted to modern environmental conditions. Just as cavities, which used to be rare, are now common because teeth are poorly adapted to the effects of diets rich in sugar and starch and our oral microbiome, many chronic non-infectious diseases have become more common and severe because humans never evolved to be almost always physically inactive. Two kinds of data are needed to test hypotheses of mismatch. First, since all diseases result from gene-environment interactions, mismatched diseases are predicted to be caused by recent changes in environments, not genes. Second, mismatched diseases are predicted to be rare or less severe among hunter-gatherers and other populations for which the environmental variable in question remains similar to the ancestral condition. In terms of the first line of evidence that a disease is primarily caused by recent environmental changes that interact with ancestral genes, we know enough about the etiology of some common diseases. For example, type 2 diabetes, heart disease, and osteoporosis, to state confidently that recent changes in physical inactivity play an important role or causal role in their increased prevalence. However, the etiology of many other complex diseases for which physical inactivity is a major risk factor, for example, certain cancers and Alzheimer's, is not well enough understood to diagnose them as a mismatched disease or to be sure of what factors cause the mismatch. Lack of data is even more problematic for testing the extent to which hypothesized mismatches are rare in hunter-gatherers and other physically active populations. There have been several efforts to collect data on health and disease among such populations, reviewed in Lieberman 2013, but sample sizes are small, modern diagnostic tools are often unavailable, and they often necessarily rely on anecdotal information. Despite these and other concerns, the evidence overwhelmingly indicates that many, if not most, of the diseases for which physical inactivity is a major risk, and many populations of subsistence farmers. As an example, comprehensive medical evolutions of Kalahari Bushmen from the 1960s and 1970s found no evidence for coronary heart disease, hypertension, diabetes, dyslipidemia, hearing loss, and more. In fact, contrary to common belief, these and other studies indicate that life in the Paleolithic was not always nasty, brutish, or short. Although infant mortality is high among hunter-gatherers, studies have numerous foraging populations indicate that individuals who survive the first few years of life can expect to live to their 70s or older. Furthermore, these individuals continue to be highly physically active as they age. As a result, it is reasonable to hypothesize that there was probably little selection to prevent mismatched diseases caused by physical inactivity, even in old age. So, what about the efforts of recent selection? Natural selection did not cease with the end of Paleolithic and, in some respects, may have been accelerated by farming, which drastically altered the environment and increased population sizes, hence the number of available mutations. For most of the farming era, people still had to work very hard, making physical inactivity rare for all but a few privileged individuals prior to the post-industrial era. In addition, mismatched diseases that are caused by physical inactivity tend not to affect people until they are post-reproductive. Since grandparents are no longer needed to forage for their grandchildren, it is unlikely that there is strong selection for mutations, if they exist, that protect against the effects of physical inactivity. Finally, while natural selection is still ongoing, cultural evolution is now a much stronger and more rapid force. The result is that we have set in motion a new dynamic, which I term this evolution, in which we get sick from mismatched diseases caused by novel environmental conditions, such as physical inactivity, and then devise cultural selections to cope with their effects. Because the causes remain prevalent and we are able to buffer their negative effects, we create a positive feedback loop in which the diseases remain prevalent or become more common and severe. This evolution is not a form of biological evolution, but instead is a form of cultural evolution that results from the interaction between biology and culture. In the case of exercise, physical inactivity is causing growing numbers of people in the developed and developing world to develop coronary heart disease, hypertension, type 2 diabetes, osteoporosis, and more. Although these diseases cause considerable misery, not to mention great expense, they are an example of this evolution because we have devised technologies and symptoms of these diseases for extended periods. Although we can and must continue to treat to treat those who become sick by promoting more exercise, especially among children, we would break this pernicious positive feedback loop by preventing the diseases from occurring in the first place. Well, yeah, there we go. Is there actually much left? Well, there isn't much left. Let's read it. Conclusion: is there an evolutionary-based prescription for exercise? In short, while physical activity is unquestionably a potent medicine, it never evolved for that role. Instead, humans' evolutionary legacy as physically active endurance athletes on the margin of energy balance has resulted in a myriad of adaptive dose-response relationships in which the body uses stimuli from physical activity to adjust capacity to demand in order to maximize reproductive success. In addition, a chronic absence of moderate physical activity was so rare until recently that from an evolutionary perspective, such levels of inactivity are not only abnormal but also cause pathology. Given these conclusions, does an evolutionary perspective suggest alternative ways to think about the role of exercise as medicine? And how does the lens of evolution help solve the urgent challenge of what to help people overcome their inertial tendencies to avoid exercise? These are big questions, but one evolutionary-based prescription is that we are not adapted for any particular dose of kind of exercise. Instead, like everything else, different types, intensities, and doses of exercise involve multiple trade-offs with complex effects on health. Thus, while exercise is an effective prescription to promote health, there is no minimum dose, no optimal dose, and no dose without risks or negative consequences. For example, while exercise has many benefits for cardiovascular function, it does not prevent all forms of heart disease and may actually be harmful in certain doses. But put differently, an evolutionary perspective predicts that while an absence of physical inactivity almost certainly increases the chances of morbidity and mortality, exercise is not a guarantee of good health and inevitably involves trade-offs. For example, people who exercise to lose weight have to cope with increased hunger and metabolic shifts, presumably because these reactions are adaptations to regain energy balance. A second major conclusion is that while humans are adapted to be physically active endurance athletes, we are just as adapted to be inactive whenever possible. It is natural and normal to be physically lazy. No one has ever done the experiment, but I predict that hunter-gatherers in the Kalahari or the Amazon are just as likely as 21st century Americans to instinctually avoid unnecessary exertion. Although a small percentage of people today exercise as a form of medicine, doing their prescribed dose, the vast majority of people today behave just as their ancestors by exercising only when it is fun, as a form of play, or when necessary. An evolutionary perspective therefore predicts that the most effective ways to promote exercise will be in these two contexts. It follows that we have two urgent challenges, which are appropriately the focus of many worthy initiatives. The first is to devise ways to make physical activity more enjoyable in schools, workplaces, and other environments. The second is to restructure our environments to require more physical activity. The bottom line is that just as cultural innovations are causing the physical activity epidemic, new cultural measures are needed to restore the need to move in our environments. Until we do so effectively, we can expect to remain trapped in a pernicious vicious cycle in which, by treating the symptoms rather than the causes of diseases that are caused by physical inactivity, we will permit the exercise paradox to persist and worsen. And with that being said, and with great insights and nothing much to say anymore, I wish you the best. Please think about that and keep in mind what role physical activity plays in your life. Are you active enough? Are you inactive enough as well? Which is definitely always and also something to consider when you are an athlete or very physically active person. Do you need to rest more? And I've also seen that in my life. Guess what? By overdoing things, you're probably hurting yourself as bad as by doing too less. But yeah, I'm gonna see you the next time. Bye bye.